Let us see the mesh current analysis or loop current analysis method. So before going to see in-depth of mesh current analysis method, we have to know about why we go for mesh current analysis. So normally in before videos we have seen about Kirchhoff's voltage law, Kirchhoff's current law, etc. So these are the different laws which is used to find the unknown parameter of voltage and current. So with the help of KCL, that is Kirchhoff's current law, for small circuit, if we want to find the unknown parameter of current, we can easily find the current. Similarly, by using KVL rule, unknown parameter voltage can be find for small circuit. In case the circuit is complex and more number of resistors, inductors, capacitors are connected in the particular circuit, and it may be DC circuit or AC circuit, at the time we have to concentrate more to find the flow of current in the particular branch and voltage across the particular branch. So for this we have to consider different kind of methods. So for mesh current analysis method or loop current analysis method is used to find the unknown parameter of current. Similarly, nodal analysis method also available for finding the voltages. So these are the two important methods, mainly concentrate in electronic circuits to find current and voltage for complex circuit. To overcome this problem, we focus to mesh current analysis method. So let us see the example for mesh current analysis. So here we consider one circuit. That is, here I just give the question, find the mesh currents I1, I2 for the circuit shown in the figure. So in this circuit, two voltage sources are connected. So the voltage source, one value is 9 volt and 2 volt voltage sources 2 volt, and 3 resistors are connected like this, 2 ohm, 4 ohm and 3 ohm. Let us see the mesh current analysis method, and with the help of this concept we can able to find the current flow through this mesh 1 and mesh 2. So for solution, initially we have to redraw this given circuit and we have to identify how many number of meshes or how many number of loops are present in this circuit. So I just redraw this circuit. So the same circuit is drawn here, and this one part is connected as one particular loop or mesh. For example, this is 2 ohm is one branch and 3 ohm is another branch. This 3 ohm is connected with this 2 ohm and also 4 ohm. So in between of these two branches, the 3 ohm resistor or circuit element is connected. So here we can consider this particular loop is called as a mesh or loop. So for example, if I consider A, this is point or node is A, here it is called as B, C, D, E, F. So here I can say A, B, C, F. A is one mesh or one loop, and B, C, D, E, B is another mesh or another loop. So both mesh and loop are same. So this is a concept. So all meshes can be considered as a loop, but all loops are not able to consider as a mesh. So this is the basic concept we have to remember. So after that, from this given redraw the circuit, we have to identify the mesh 1 or loop 1. From this loop 1, we have to identify the mesh equation. So we can write this mesh equation. So here the current is flow from minus to plus. So here we have to put the minus 9 volt. So plus, and the resistor value is 2 ohm, and which is multiplied with this current I1. So because this loop is considered as a first loop or first mesh. So for particular resistor, what is the current flow through this resistor? I1. So minus 9 volt plus 2 I1. Plus, now the 3 ohm resistor is connected in between of mesh 1 and mesh 2. So if you consider this particular first mesh 1, first you have to consider 3 resistor value into I1 minus I2. Because if you consider first loop, I1 minus I2 should be present. In case if you consider the second loop or second mesh, we have to consider the current value I2 minus I1. So for first mesh A, B, E, F, A, minus 9 volt plus 2 I1 plus 3 into I1 minus I2 equal to 0. So this is the mesh equation. So after that we can rearrange this expression. 2I1, that is 2I1 plus 3I1 minus 3I2 equal to this 9 volt is now moved to right hand side. So plus 9 volt. So now add this to I1 because we have to separate both I1 and I2, which is helped to form the matrix separately. So 5I1 minus 3I2 equal to 9 volt. This is first equation. Similarly, for considering loop 2 or mesh 2, we can consider B, C, D, E, B. So for this we can write the expression 4 into I2. This is 4 into I2 and current is flow from minus to plus polarity. So minus 5 volt plus the resistor 3 ohm is connected in between of mesh 1 and mesh 2. So 3 into I2 minus I1 equal to 0. Again rearrange this expression. 4I2 plus multiply this 3 into I2 plus 3I2 minus 3 into I1 equal to 5 volt. Now minus 3I1 plus 7I2 equal to 5 volt. So now these two are the expression for mesh 1 and mesh 2. So whenever if you have two loops or two meshes, we can able to find the two mesh equations or two loop equations. From this equations we can able to form the matrix. Now we can form the matrix from the given equations. Here 5 minus 3 7 into I1 I2 equal to 9 5. So with the help of Cramer's rule we can able to find the current value I1 I2 I3. So for finding I1, del 1 divided by del is the formula. Similarly for I2, del 2 divided by del is the formula. For I3, del 3 divided by del is the formula. Now it is only 2 cross 2 matrix. So now we can able to find the del value. We just take this matrix 5 minus 3 minus plus 7. So cross multiply these two values and finally we will get 35 minus 9 equal to 26. This is del value. And del 1 can be determined. Now del 1 which is equal to 9 5, that means the right hand side value of matrix equation can be taken 9 5 and we can put it in first column and the second column of this matrix value is same and it is retained here. So 9 5 minus 3 minus 7, so which is equal to 63 minus 5 into minus 3. So finally we will get 63 plus 15 78. So del 1 value is 78. Similarly del 2 is we can just take the first column value from the matrix 5 minus 3 and the second column value is replaced by 9 and 5. So 5 minus 3 9 5 is taken in del 2 and 5 into 5 cross multiply and 9 into minus 3. This is the second term and finally we will get 52. So this is del 2 value. So here only 2 cross 2 matrix is there. So we can able to find only I1 and I2. In case instead of this 2 cross 2 matrix, if our equation is 3 equation, we can able to get but I1, I2, I3 3 equations and the current also I1, I2, I3. For that we can use this entire I1, I2, I3 formulas. So in this case only 2 current we need to find. So del 2 is 52, del 1 is 78 and del is 26. So from this del I1 is equal to del 1 divided by del, which is equal to 78 divided by 26 3 amps. Similarly I2 equal to del 2 divided by del 52 divided by 26 2 amps. So finally we found I1 is equal to 3 amps, I2 is equal to 2 amps. So the mesh current analysis method, otherwise called as the loop methods or loop current methods, which is mainly used to find the unknown currents, depends on the number of meshes or loops present in the given circuit. So reduce the complexity of the circuit, we go for this mesh current analysis method for finding unknown current values.